This is probably the fifth video I did in a series where we're discussing filling out the application for NEM 2.0 grandfathering. And I'm going to focus this video on the single line diagram which is needed, and it just needs to be done without major deficiencies according to Edison, and I suppose that PG&E would have the same feeling. So this video is going to be discussing just the single line diagram, and I am not an electrician. I have done some DIY projects, and I'm helping people submit their applications now just as a homeowner, and not an electrician. And this is not a design document, or this is not a design video, although there are some elements of that. Mainly, it's just to be able to fill out a single line diagram without any major deficiencies according to, and that's what's required. And then you have probably about, hopefully, 3 years to install your system once it's accepted. So what we're going to be doing is using the solar permitting guide for California, and that allows homeowners to just go into their building safety department, and pull a permit as owner. And it is the minimum set of documentation you need, and it should be readily accepted by your permitting office. However, for this exercise, we are just focused on getting Edison or PG&E to accept this document. We have to put enough details into accept without any major errors. So we're going to be going through these elements in the single line diagram, and I do have I did download real quickly the uh, the solar permitting guide, and so you can see this page right here is just from the guide, and I just kind of typed over it with a PDF. But I also have an example where I have done a line drawing here, and I just used pencil and then scanned it, so that would work also. So let's just go over these elements that I have here. We can start discussing. I'm assuming that you're gonna have to. I've done other videos where you're gonna estimate your the number of panels you need, and you just need to call out the number of panels you need. We're going to be focusing on the load side here, and we're going to be focusing on, I think, the simplest thing for you to do, and that is to have microinverters. So we're going to focus on using the IQ8A microinverters with any sort of panel of your choice. So let's start with this checkbox. We're going to check ungrounded. That will work. And I'm going to go a little bit heavier into this. On the main panel, you go out to your main panel and you look for the main breaker in your main panel. And that is going to look something like this. So you go out and you look at the main breaker, and sometimes your panel will also have a bus bar. You'll also be able to read what the bus bar is. So in general, we need this, and we don't really need to add up all of our breakers, but just for the heck of it, it might be nice for you to add up the sum of your breakers. And then we're going to list the main breaker here, and we're going to list the bus bar. And if you can't find it, then it's probably most conservative just to list the what your bus bar is. Um, let's jump this protection breaker. It's a subject that we're going to have to talk about. Um, so what happens is the protection breaker needs to be can have a maximum size. This is a backfeed breaker. We're going to actually put this backfeed breaker on the bottom of the panel here, and that backfeed breaker size it is limited by what your bus bar and your um, and your and your breaker is that protects it. So this is a formula that I created where you have 100. You say your bus bar times 120%, and you multiply that, and then you subtract what your circuit breaker is, and then that's the most that you could possibly put in this panel. And so that is going to limit the size of your system. So I think to make it free of any major deficiencies, you want to make sure that this formula is kind of followed. What you need from the system. So let's take a look here at what we're going to do. Here's the so basically we came up with for a 200 amp panel and a 200 amp bus bar, you've got basically 40 amps max, and for a 150 amp uh, panel and bus bar, you have 30 amps max for. But for some reason, if you have a 150 amp um, uh, circuit breaker and a 200 amp bus bar, you can put it up to a 90 amp breaker. So some of you are going to have to look at this and see if your panel is limited in some way by how many amps you can feed into it. And if it is limited, you may have to derate the breaker here to be able to get the right amount of amps in backfeed through here. So, because what we're doing here is we're taking all the PV arrays, feeding them into a circuit, and then we're going to that circuit is going to terminate into a a condenser box, and that condenser box is going to just each have a breaker in it, and then it's going to feed all the way back to the main panel. But we have to make sure that we're not having too much power here and not enough breaker capacity here. So for that, what we have to do is we basically one of these IQ8A microinverters that go with the panels is going to feed a maximum of 1.45 amps back to the main panel. So you basically have to just add up all the IQ8As that you have, and then and by the way, those are being protected by 20 amp circuits right here. So you can see that this branch circuit right here is I only have one in this drawing, but this one is being protected by a 20 amp circuit. And it so happens I only need a 20 amp backfeed breaker right here. So we have to add up all our IQA circuits and make sure that they don't that they're within a range of what this breaker is. Otherwise, we have to take some action, right? Let's see now. we went over uh, the IQ8A and maximum 11 panels per string. So you have to kind of fire up new strings if you want to. If you want to, you can't exceed 11 on this IQ8A. So let's look at this. This part of the device is is a monitoring system for for your solar production, and we don't need it. This is a disconnect that runs between the utility and the combiner box, all these branch circuits, and we absolutely do need this, and it has to be sized. Uh, Again, to be 80, probably 80%. The good rule is it's an 80% rule. So whenever you're talking about circuit breakers, you want to have whatever your amps are, you want to multiply by 80%, and that's what the protection is. So what we have here is a rough ampacity for the type of wire that we could run in these conduits. And we have to, in the single line drawing, call out what wire we're using. So as you can see here, I have called out 10 gauge 10 wire on A. So all this conduit here that runs over from the combiner box over to all the microinverters, that one is going to have number 10 wire, and that number 10 wire is rated to 40 amps, and we're using a, which would normally be a 30 amp breaker, but we don't have to worry about that. Enphase just basically says use a 20 amp breaker. The most you can put on there is 11, and we're well within the specs there. So you can get away with number 10 wire right here. And the other thing is, now for this conduit here, all this combiner box stuff is getting accumulated and going back through this wire to our panel breaker. So we need to make sure that this breaker size is in range, and the wire is good enough to handle all that load. So number 8 wire will take you to 55 amps, and then of course you have to derate the breaker, that you're protecting that with. But chances are it'll already be kind of derated by, if you've got a problem with this panel. Um, so anyway, your breakers over here have to match, and you could do more research on this. Have to they're constrained by the bus bar here, but you have to also keep in mind that you're protecting this wire. So if you have a low value here, it's going to have a higher degree of protection. But in general, if you're going to have more of these branches, you're going to have to make sure that this has a higher ampacity to take the existing load, and you're going to have to make sure that that this breaker probably is going to have to be a little bit bigger. So let me show you another single line diagram that I did for a bigger system. Here I was running 2 strings. I used number 10 wire, and it was a pretty big system, so you need to run a ground that I think a number 8 gauge ground is a good idea. It's not current carrying, but it's an it's an 8 gauge ground wire, yeah, and that's basically gonna hook up to your panels, and then those panels are screwed into the microinverters, and that's going to provide a ground. But you can see here that for current carrying here on B, I ended up using number 8 wire. So the number 8 wire is bigger wire because I had to go and take all the current from the combiner, and it was a lot more current. Of course, I also had a 200 amp panel, so I had to upgrade. I upgraded my breaker here to a 40, and the other diagram you just saw a 20. So you could use this, roughly you could use this diagram if you had a lot of stuff to put down, and you'd probably be okay getting away with, the 8 gauge or possibly a 6 gauge wire. Might actually be better here in this area. And then I'm just kind of showing you that I used two current carrying conductors here and two current carrying conductors here. So let's see if I can get this one going again. All right, so we discussed, I think, all this that we need to discuss. So it's important that you have the number of panels you're using, the exact model number, and then the exact model number of your microinverters. And you could just copy this. The in phase 3S is the combiner. I think I have a combiner here. So here's an example of a combiner you could use. And that basically has technical, and it basically, this particular one's an 80 amp, which I didn't. See, that's an 80 amp with 3 ES. Actually, that should say 80 amp bus bar, I guess. And the squared E is 3-phase ES. I think I did. No, that was a combiner 4. So anyway, I think I did do it right on the other diagram. But anyway, this one happens to be 65 amp. Let's see. I think just the copper, you need to make sure you need to kind of call out this copper, and everything else should be working. So I don't really have anything else to add to this. Leave your questions. I thought it would be good to go over the panel sizing constraints just so you didn't get into trouble with that when you're sizing your system. I wish you great luck on your project. Please read the comments. Other people are having problems. I could have made mistakes here, and then I usually correct them in the description or the comments by talking with others. And I would appreciate it if you liked this video. Thank you.